next speaker is Jim Chung, and he's making his way down. He's going to talk to us about an International Space Station transit. Some kind of world record, Jim?
All right, well, good evening. You guys hear me okay? So before I start, in case you're wondering what this is, it's Star Trek Phaser 2. I made this a couple of summers ago because I was doing a star talk at a winery on Niagara Lake, and the beam path was really good to point out stuff in the sky. So I needed a pointer. I wasn't sure if we'd have one tonight. So I don't get a chance to use it very often, so I thought I'd bring this along. See? You got the full disruptor setting too.
Is that set on stun?
Well, there is a stun, and then there's a kill setting on. So tonight, let me introduce you to the world's first dual solar and lunar international transit capture. So a solar or lunar transit is simply the passing of a celestial body across the face of either the sun or the moon. And in this case, it's the space station that we're looking at. So back in 2012, I was very fortunate, along with several members of the Toronto Centre, to be at the CAO to witness the Venus solar transit. So this is my high-resolution image of that event, cropped, and obviously a once-in-a-lifetime event because next time it happens, we won't be around. My actual first International Space Station transit that I witnessed was of the full moon. And I can confirm that Blake Van Carroll was there, even though he doesn't like the full moon. We were freezing in December of 2011 at 3 o'clock in the morning, all hunkered at Humber Bay Park to see this. And you can see that's the little station right there. And then in 2013, I got a nice high-resolution capture of the solar International Space Station transit. And you can actually make out the detail. You can see the solar panels, and some of the individual modules actually are visible in that shot.
Wow, that's really amazing.
So obviously you have to be at the right place at the right time to see these things. And there are websites which help you determine where to be at what time, what day. I use calsky.com. And they're nice because they give me an email with notification a week in advance of a transit within easy driving distance of my home position. So you have to be at the right place. They provide a map. At the right time is important because the transit really occurs under 2 seconds. The right day is critical because it typically has to happen on a weekend or a day that you're not working. So it really limits how many of these transits you can actually conceivably and realistically see. As little as 5 years ago, you needed some rather esoteric equipment to capture these events. You needed a camera with a big enough sensor that could fit the entire disk of the sun or the moon in it. You needed a camera that was pretty fast, that could shoot 30 frames per second in that area. You also needed a fast interface that could download all that uncompressed image data to your laptop. And to be able to also record for at least 2 to 5 minutes, because the event times might not be perfectly accurate, so you want to start maybe a couple of minutes before and a couple of minutes after, just to make sure that you're not missing it. But luckily, technology progresses, and there's a lot of DSLRs and mirrorless cameras that shoot 4K now. And 4K video has made it possible to basically have the processing power of a laptop built into the camera. And the camera also has what's called an electronic global shutter, so you can shoot 60 frames per second, maybe even faster. So this is from 2016 over my house with an Olympus mirrorless camera, and there is a station there. So back in September, I got this notification. It said that the space station would cross the sun, the rising sun on a Sunday at 8:20, And then, unusually, it would cross the setting moon 92 minutes later, basically on the tail end of a complete orbit, all from within the city of Toronto. Now, I've never seen this before, and I've never actually seen anybody else post an image on the internet of a transit that occurred at the same time of the sun and the moon. So I'm hoping that this is the first time. So CalSky tells you where to be. So you have to be on this center line to see the solar transit, and you have to be on this line to see the lunar transit. And of course, the easy thing is to be in one place and not have to move, which puts you in the middle of the lake. So luckily, you don't have to be exactly on the line. You can be within 2K on either side, and you still have a good chance of seeing it. And so what I did was I found this little park here, and I sort of split the difference. I was kind of in the middle of both paths, and that worked out fine. Great. So you can't miss it. It's pretty easy to see at the sun. There it goes. And that's live, yeah. That's about 2 seconds, so we'll play that one more time.
Okay, what scope is this with?
This is with a Coronado 40 millimeter solar scope. So it's about a 500 millimeter focal length. Okay.
60 frames per second.
That was probably shot at 30 frames, but close, yeah. So I'll just collapse that in, and I just open up the
moon. One more.
Okay, we'll do the moon too. Okay.
And was that in real time? Not speed up, not slow
No,
down?
yeah, it's real time. That's right. So, okay, this is where you, right there is where you have to look for the space station, because there's another satellite that happened to pass by at a higher altitude. So we'll play it again. But what you need to do is sort of look in this area of the screen for it to appear. Here we go. So there's that high altitude one, and then you'll see the space station roar by. There you go.
Oh, wow.
Yeah.
You're holding your breath the whole time?
Yeah, definitely. Okay, so we'll go back to the slides though.
What are you trying to do? One more time.
Let's see one more time? Okay, sure, why not?
It comes in this way.
And Jim, that obviously was with the Coronado, so what scope was that with?
The Coronado.
It was? This was?
I'll explain why, because it's obviously nothing ever goes to plan, so that this is a good example of what happened. So how do I? Was it one more time? Okay, because I have no idea how to collapse this image anyway. So, all right, I'll see it again.
There. It does, but it's pretty fast. You can't see it.
Okay, and so this is what it looks like after you stack it and give it some color and then paste on the space stations. I just inverted it to make it a little bit more visible. And so what happened was Mike was asking me what I shot the lunar one with. I only brought one scope, thinking stupidly that I could shoot the moon with a solar scope. I thought the moon might be bright enough, but of course it's not. It's completely useless. And I didn't have time to go back home because I didn't want a chance driving home all the way and then coming back and being late to set up, because you have to polar align the mount all over again and get set up and put all your gear out. So what I did was you can't really use the diagonal that comes with the Coronado solar scope because it's got a blocking filter and it's very dense. It won't let any light through. So I took it off and I just stuck the camera on the end, but there's not enough focal travel without the diagonal in its place. So I had to unscrew the actual lens objective reversed it. I found some stuff in my first aid kit in the car, and I wrapped it around, and I shoved it back in backwards, just to have it sticking out more. And then that just managed to get into focus. I stuck a red filter on in front because I knew the moon was very low in the sky, so it was going to be a very turbulent atmosphere at that level. So I thought the red filter might help with sharpness. And yeah, you saw the video already. And this is what it looks like graphically after you stack it. That's the path of the space station. I flipped it because on the video it's inverted. This is the way it looks like in the sky. And this is the path of that unknown higher altitude satellite. And this is the final version of that image, which I still think is the world's first dual solar and lunar transit, ISS transit. And you saw it here first. And that's it. I end all my little talks with photographs. So this is ballroom dancing, a couple doing a waltz. To all the guys out there, you have to spend more time with your wives. My wife wanted to do ballroom dancing this winter, and I said, no way am I doing that. But she said, well, I'd like to. So I said, well, I have to then. And, you know, the better you get at it, the more you start enjoying it. Good night. Thanks. Any questions?
I've got a comment, actually.
Please.
You actually look quite different when you're dancing.
Not me at all. I could never do that.